So, hi, Marco. I'm sure you haven't seen me before. Well, maybe people on some, and people in the future, but well, yeah. So I'm only making a little introduction about R and like some management tools. I'm not gonna use dplyr. It's gonna be only like R core, some R core based functions and stuff like that. And so I like a lot of memes. So I try to make it as fun as possible for you because code is scary. And also I try to make it fun for me because speaking in public is scary. So it's a win-win. First, I'm gonna do like a really quick introduction, and then we're gonna go to the fun. So for this, if you could like download the things that you can find either on the Google Drive or on my GitHub repo when you have another meme. We're gonna need the Markdown, RMD, and well, the HTML if you want to see, as well as the images and the data that's underneath that. Also, if you go to the Google Drive R session 1, you're gonna find everything you're gonna need. So that's quicker also. So in a nutshell, what usually media tells us about programming is that it's about like glowing fonts, screen, and shouting, I mean, and that coders are nerds. So yeah, I code, I'm a nerd, but not everyone who codes is a nerd. Well, the reality is that it's mainly about making and solving errors. So coding is like a puzzle. And because we are humans, we are gonna forget what you had already solved and you're gonna make new errors. But you have to find the fun on that. So the thing like I would like you to remember is that everyone can code. You don't have to go super efficient. It's like one step at a time. And if it's wrong, don't change it. Leave it that way until you can figure out how to make it cooler. Also, most of the times media tell us like about people like programming like all by heart memory. So that's not true. We use a lot of internet. God bless internet. So you can use Google, Stack Overflow, Google Gemini, who is like a generative language model tuned for coding. So that's good. It's better than ChatGPT, and you can use ChatGPT as well. They are both large corporations, so they are still as harmful, same as harmful. Also, you can go within the RStudio help and the cheat sheet to see like some help about how to do stuff that you would like to do. And also you can download like this really big thing that has a lot of scary things, but that you are gonna get one time at a time. You have to learn everything at the same time. You have to get like one bit like a time. So you don't, it's not a good call to eat a whole cake by yourself, but maybe you can eat chunks of it. And then you're gonna have it by the end of the day. So I add some literature and also within the slides some of the women programmers because well, mainly in psychological science is represented by women, and there's like the stigma about women not knowing to code. Nonetheless, women were the first coding, and then when it became profitable, we broke codes crashing. So there are some people you would like to look at them. Also, these are computers, so women making maths. And about there's like this initiative called Our Ladies, because broke codes are usually not really nice to people, especially not to women. So you have like any code questioning, you can go there. They have like some tutorials and stuff like that, and they are trying to break the gender gap. There are some recommendations readings about this that you can find also over the recommended lectures. And a computer science crash course if you want to get nerdier. And that's all. Then I'm gonna go to the actually HTML. So do you have downloaded it? Do I wait? I'm gonna wait. Well, you can see Baby Yoda. In the meanwhile. It's this one, the QR. Yeah, I'm Marco. My username is Marco7877, and the repo is BCBL Pupillometry Workshop. Also, you can find everything over Google Drive. So if you go, hide video panel? No. Which names? No. Fine. So if you go over here, and then is this one? No. Our session 1, you're gonna find everything you're gonna need here as well, so that you don't have to do scary stuff like Git. Oh my goodness. When I get nervous, I usually speak really fast. So if I do that, please let me know, because I'm nervous. Good. Okay, so I'm gonna start. So the way I think about it is like making a joke about Jedi pads and making some Lord of the Rings references. So it should be fine. So the main difference, or the first thing that we have to think is like, what's the difference between R and RStudio, right? So R is a programming language, a high order. That means that we can talk over a TXT file. And then R is going to be smart enough to translate it to computer language. So instead of having to write this, that's binary, that if you go to a translator of binary, it's going to give you a phrase. So that's what the R compiler does for you. And RStudio is a graphical user interface, a GUI. So that makes us really easier to move around. So R is only a TXT file, like a .txt, but with a fancy extension, .r. That could be a .csv. R is translating that to computer language, and then it does brrr, and we have nice plots. For this, we are going to use Markdown. That Markdown is like a wrapper that lets us makes join chunks of code as well as some text-based stuff written in Markdown. So this is like, in a nutshell, the graphical user interface. You're going to be able to have here like the packages you have downloaded and installed. You have a help viewer. You have a viewer. You can see some plots in here. Algo pasó. You also can browse around your directory. So you can do this, and then you can go back in case you don't remember where you are or where you're like trying to find stuff. Here you have our environment. They're going to see like step on step. We have the console. So this is the thing that translates things from high order, like human-like, to computer. We have a scary terminal that in my case has a penguin. And we can see here like the jobs that are going in the background. We can open different kind of files because it's a GUI. So you can have different amounts of TXT files open here. So the good thing about RStudio is that you can open Python, you can open TXT, you can open a lot of stuff within here without having to migrate to another graphical user interface. But also, if you want to do it, it's totally fine. It's your computer, it's your amount of memory. So the first thing that I want to step about is that you can use R as a calculator. It can translate stuff. So for example, here I'm using a sum, really straightforward. this is a chunk of code. You can see that it's delimited by these quotes and then the R, because whatever is inside that there is going to be run in R. Well, so we can click run, and it gives us the answer. Really smart, right? We can also do subtractions. We can do divisions. We can do multiplications, exponentiations. And we can do really scary stuff. So because we can do like really basic arithmetic stuff or calculations, we can pile them up to make like really, really big stuff. So a good thing about, or something that you have to keep in mind about this is about the relevance of each one of the math notation. So you have to remember PEMDAS. The first thing that they're going to be running is everything in parentheses. So here, where I'm trying to get this amount of days that you get from the year 0 to the 2024, given that we also have años bisiestos, that every 4 years we have 1 day more. Yep. So before getting like this really scary number, what this is doing is first we're having a multiplication here because first are parentheses. There we are doing this this division, and then we are doing an addition. Thus, if we do something like this, I think it's gonna change us. Nope, but maybe like this. Sorry, I don't remember PEMDAS. Oh, but let's do. Ha! So sometimes you're gonna get different kind of results. You have to be really aware about how you are delimiting the operations you want to make. And even though it may not look really nice, at least for me, that I'm a linguist, it's really useful to put always a parenthesis so that it's a little bit more human readable. Also, I forgot, I thought about a joke like at the beginning. The idea to make this is like to speak into my people and not like Mexicans, but people from humanities. The thing about R is that we can do these kind of calculations, but it's still, instead of using numbers, we are gonna use some scary things called variables. Variables, you see? So what's a variable? A variable is a data item. So imagine you're an elf, right? And you have magical points. But magical points get decreased over time, and you want to store them. So then you go to a rock, you go to a scroll of paper, and you infuse that with your magical power. Then, in that case, the rock or the scroll would be the variable. It should have a name, so you could call the rock Rocky, and then Rocky would be the variable that contains the MP in this case. If we translate it to computer, you have a variable that's a name that contains something. So this is the basic notation to write variables and to assign them within R. And you can check two things. First, we have a weird arrow. That's because in R, there's a difference between having the arrow that's assigning 10 to the variable name my number, and the equal. If you use the equal instead of the assignment, sometimes you get your data overwritten, because that's saying that what's containing in one variable is the same as something else. So if you change something else, that's also going to affect your variable content. It's always better to use the assignment. Why they did that, I don't know. Also, it's really a good call to have like our variables human readable and easy to understand for us humans. So in our notation, to separate variables, we use a dot, and that maybe a little bit triggering for MATLAB users and Python users because you are not using really an object. Well, they decided that way. Okay, so we have different kind of variables. We can have numbers. My number is of class my number. We can have strings. Class my letter is character. And we can have really long strings. So if you see, like, the only thing about this and this that's in common is that they are delimited within quotes. So that's saying to the computer that everything within quotes is going to be treated as text. So you can put a number within quotes and it's going to be text for the computer. You're not going to be able to do some math with it. And also here I'm doing something. Our first command. So if we go here and we run, by the way, if you put Control Enter, you're gonna run line by line. So I run my number. And as you can see here within environment, I have the number of my variable, the name of my variable, and its content. I do the same for this. Oh, it's magic. Then I can do the same for Robotare en Agurra. And if I run the print one, I'm gonna get hello world. So you may not have noticed, but we have run our first command. We have, yep.
Yeah.
Yeah.
Yeah, what if we assign the variable my letter equal thing after this assignment?
It's okay, yeah.
When you break the value, when you set up assignment this way, means the variable here is treated like public. Cannot be changed.
Yeah.
I don't know.
So let's. I'm gonna. So here I'm gonna assign a new variable, my number 2. Here I'm gonna sum to my number 1. And in this case, it didn't happen that much, but sometimes you get data overwritten. Because the thing is, they were like trying to kind of copying C++. So the assignment is because like they are assigning to they have a pointer to a space, and when they have the assignment is that they are like copying a variable to another one. Sometimes I don't really know precisely when you affect one variable, the other one is also gonna change, because it's a difference between having an assignment that's gonna point you from one space in memory to another one, and a process that's only pointing to one space in memory. So what we did here, well, not here, is that we asked the R compiler to print Robotare en Agurra. And it's exactly what it did. It printed, I forgot it. It printed this, hello world. We have the class, and we have another kind of really weird, really weird class called factor. So what is a factor? I don't know. Honestly, I've been trying to understand it, and I don't know. But the way it works like is something where you can categorize different stuff. So for example, imagine you have a scroll where you have names from a village from orcs and elves. They are friends. I want them to be friends. So here you can have like the name of them, you can have their height, you can have whatever thing you want, and you have the species. And this is the category or the factor which are gonna delimit or it's gonna divide the data. So in this case, if you would like to see like run a t-test between those two, you're gonna need the factor species to see, I don't know, the amount of beer consumed by elves and orcs. So yeah, it doesn't matter if an elf is an elf. Yep.
You always need to put
Like a string, you mean, or like a factor? Like a string, yeah. Yeah, you have to put it on the quotation marks if you want to do a string. Factors can be also numbers. Like you can put like instead of having my factor as factor, you could have here this. And this is still here, even though it's recognizing that set2, it's translating it to kind of like a string, because the important thing is that it's a factor. It's a thing that's gonna categorize the stuff, or that's gonna clusterize the data. If you have ANOVA, it's gonna be your one of the dependent factors, for example. You can also use some strings to do that stuff. Thus, for the statistical purposes, functions don't work. So that's what I say. I don't really understand what a factor is. Yeah, it's something that you need to categorize data, even though you can do it with strings. And that works for mixed effect models, linear models, and stuff like that. Basically, everything that you're gonna do with stats is very good when you can do a factor, because also that means you can do some contrasting. So for example, if you have a multivariate variable and you want to get the intercept between all the levels of the intercept against one level, you have to convert them to factors and then to get the contrast matrix. It doesn't make sense, but it makes sense. But I don't know. Sorry.
Sorry, can I just ask if I understand correctly?
Yeah.
Then what you did, you created the variable my factor, which is the factor variable, and I didn't get what is this level.
Oh yeah, because here I only have two, but for example, you could have 2, 3. Whoop, I got an error. Let me see. Levels equal, let's see. Yep, I'm gonna make that as well. Levels. We have the variable my factor that contains 2 levels, which are 3 and 4. And if you click on it, you can see it. Let me see. No, you cannot see it. But well, yeah. Yeah, factors are weird, but they are gonna be useful.
But then when you created the new variable, the new factor variable, each element in the inputs to create the variable is going to be like the name of the level. Yeah,
so yeah, that's a good question. You have a variable. Imagine you have a variable containing a lot of strings. The way that the factor is gonna be applied is that every unique occurrence within the variable is gonna be treated as a level. So if you have like some spelling mistakes or some like spaces, it's also give you an error. So you have to be really careful about that. Does that make sense?
Yeah, so like if you have like a condition, like random assignment to A, B, and C, and you mistype a capital B as a lowercase b for one of your participants, it's gonna think they're in a different group.
Yeah.
Let's show the condition.
A, B, and C, yeah, which is just great for modeling. Like
Yeah. What Drew was saying is that, well, is that if you have a capital B and a lowercase b, well, when you transform them to factors, the computer's gonna think that capital B is a different factor than lowercase b. And I have a meme about what it rings. So if I'm not gonna be clear enough, surely. So please go around the HTML, because it may be funnier than me. It will be, hopefully. So we know know how we can assign some data types of some data within variables. We have another thing, like another level on top, which is called like data structures. Sorry for the vowel. So maybe you would like to have many elements within a variable, because it's not really efficient to have one variable containing only one element. That's not efficient. So when we do that, we call that unstructured. It doesn't make sense. It's just the way. So imagine you are the same elf, and now instead of wanting to save or allocating one spell within one rocky rock, you want to allocate a lot of healing spells within the same rock. In that case, you would need a data structure. And you can do several things. You can allocate a lot of healing spells within the same rock, and that would be an homogeneous data structure. So they are all healing spells. Or you could want to allocate different kind of spells like healing, explosion, light, whatever, because they are different types. So in this, that would be an heterogeneous data structure. So that could be like having numbers, strings. First, the vectors. Vectors are one-dimensional data structures, and they are defined by, after having the assignment symbol, we have the C saying that it's gonna be a vector. That's how we call it. I don't know why. Do you know why?
Why is it a B? It's always bothering me.
Yeah, I don't know. Yeah, our people are weird. But also it makes cool plots. So
Would have been great. if it was-
yeah, it could be great. Yeah. So here, for example, I have my number vector. On my number vector, you can see that it says that we have from 1 to 5 elements. So we have 5 elements, and it's notating each one of the elements I was telling that there is containing. And also it's telling me that the class of the elements are numbers.
Combine, because you're combining all of the elements.
Ah, I learned something. Thank you very much. We also make vectors from strings. It's a trap. It's definitely a trap. The important thing is that you always have to put the C. And it's important knowing that about this kind of data structure, because they're going to be useful for plotting, and also because they are used for heterogeneous data types that I'm going to explain later. So as I was telling you, if I run this kind of variable where I totally make a mistake here, I have a number 1 and a string 2. If I run this, it's not giving me any error, which is good. But if I go to my vector, if I go to my vector, you can see that R said that, oh, human, you made a mistake. I cannot have a vector with different class data types. So probably you wanted to have strings, because it's easier to transform. Well, you can transform a number to a string, but not a string to a number, because imagine you have age. What number would that be? That doesn't make sense, right? So it's converting everything to a string. It says like, yeah, human, I have you covered. You are too dumb.
CHR stands for character.
Yeah, thank you. Yeah, CHR is character. Yeah, they changed everything. They don't like strings. They don't like, instead of ints, they have numbers, which are a different kind of.
They are strings. It's just,
Yeah.
it'll label it as CHR for character.
Hmm.
versus num for num.
Yeah, but still weird. Yeah.
So
Yeah. Also, it's worth notating that R was developed by people from stats. So it's really useful to do stats, and you can get like a lot of things, but they also wanted to be cool and do stuff by their own way. We find another kind of structure called matrix. And the way of thinking about matrix is that you have a vector, and then you glue it to another vector. So you have a 2-dimensional array. For example, here, I'm going to have a variable called my first log that has 4 elements, which are characters. I have my second log, which are also 4 elements, which are strings. And then I can glue them together to make a log matrix. Oop. Yep. And here we can see it, because now it's really something that's bidimensional. We have 1 vector, we have 2 vector, and it's gonna say use the place they are taking. And the only reason I can do this is because everything here is a string. If they would not be strings, I don't know, but probably it's gonna transform them to strings as well. Yep, it transformed them to strings as well. Because it's an homogeneous data class. It doesn't want them to be different. There are another kind of multidimensional homogeneous data that are called arrays or tables that are going to be really useful for machine learning and stuff like that. But we are not going to treat them here. And the thing is that they are n-dimensional, but to be honest, most of the times during our time using R, we are going to deal with CSV or Excel kind of files. So we don't have to bother about this. Also, if you want to use these kind of things, it would be easier and more efficient to use Python instead. So now is where the cool stuff begins. The heterogeneous data type. Oh no, the meme. So we're going to talk about the one-dimensional data structure that resembles the vector. So first we have one-dimensional vector, we have one-dimensional string. Vector is homogeneous, string is heterogeneous. So what does that mean? If I do the variable my list, I have a list of 4. As you can see, the way it's stated is different. So it's always useful to go see the environment for the variables. We can click on the circle, and we can see that the elements we have aware in it. So the first one is a number, the second one is a character, third one is a character, and the fourth one is a number. So we have different kind of class types within our data structure. Does that make sense? It's not translating them. And also, if we click it, we get like different. So we can declare lists by making a lot of stuff, but instead of using the C, we use the list function. Or we can tell them, like, I'm going to make a list, and then we name each one of the headers, like this one of the headers, in a particular way. So here I'm saying, oh, my spell block list has different levels, has 4 levels, where the first level, heal, has whoosh, lives has 2, the empty level is 10, because we are just starting, and we have 2 kind of explosion spells that are going to be within the same, let's say, header. Boom and kaboom. So that means that if we ask for the computer, for the first element, that's why we use the square braces. The first element within my spell block list is going to give us whoosh, which is the healing spell. If we ask for the same, but instead of using the braces, we use the $, we get the 2 elements that are inside of it. So the difference between using square braces and the $. The $, would be the equivalent in Python to the point. So it's saying, within my spell block, which one of these I want? It has a $. The $, that is called explosion. And over the other, so I need to know the name to get the actual content on this level. In the first one, I only say from my spell block list, only give me the first one. I could ask for the second one. And it's gonna give us lives. Does that make sense? Hopefully. And then we have a meme. And then we have data frames or tables. Table? Okay, table. So it's the same thing as the matrix. You have different kinds of data structure, but instead of being vectors, we are using let's say strings by now. I'm gonna change that in a while. So the thing about this is that they are made out of rows and columns, just like an Excel file. So this is more close, is closer to us. Yeah, Monday. Hey. Bigger memes. So thank you. So the way of imagining about this is they can be like an Excel 5, or they can be a battleship board game. You remember that when you are trying to kill the other submarines, like with A1, it's the same. So for this, I'm gonna make a battleship board game. So have A column, B column, C, D, E, F. Then I'm gonna, so as you can see, these are vectors. And they all have the same, well, these are nonce, but this would only contain, because they are vectors, only numbers, only characters, or only factors. And the reason this is important is because when we make our data frame, so for vectors, we have the C. For lists, we have list. For data frames, we have data frame. It gives us an Excel-like where each one of the vectors that we declared is a column. So what does this mean? If you are doing some data frames or you are using some Excel, if you have a lot of strings, a lot of characters of text, and then you have a number in there, it's gonna treat that number as a string, or the other way around. If you are making like a typo and putting a number instead of text, no. I'm doing, well, the thing is that it may mess around. If you have like numbers and then you have that type and you put a letter, only one letter, R is gonna think that everything is a string. And you cannot do additions with strings, so it's gonna give you, R is gonna be really, really mad and give you like a lot of R warnings in red. So you have to be aware of that. If we print board game, we can see that we have our columns, which have the same name of the vectors that we defined. We can see the data type that they are containing. They are like all, in this case, strings, characters. And we have a little game here. So before starting to play, how can we access these data points? So just like in Betel Navy game, we can ask for the data frame. And if we want the first ¿Dónde quedó? ¿Dónde quedó? So here I ask for the first. And it's giving me the first row. So that means that we are dealing with data frames. The first dimension, it goes for each one of the row. The second dimension, what would you think it would be? Yeah, columns, exactly. We get columns, and we know it's a column because sh. And there are also two differences about like calling each one of the columns. we can call it this way. Remember that we could do this within the list, calling them with the square braces or with a dollar sign. If we call it with the square braces, it gives us this. If we call it this way, it gives us this. So what's the difference between calling them this way or this way? What do you think is the difference? Exactly. Yeah, exactly. If you call it with the square braces, we are getting another data frame, only smaller. We have still the name and we have the row values. If we call it with the dollar sign, we get a vector. It may look trivial now, but when you want to overwrite columns or you want to add more columns, it's not that trivial. Also, when you want to make some operations, if you make an operation that gives you a vector, you are not going to be able, well, sometimes you're not going to be able to use it as a column, as a data frame structure. Sometimes it's happening the other ways around. You have something that gives out a data structure, and you are not going to put it over a vector. But yeah, it's all about making mistakes, just like life, and deciding to make a PhD. We can also give like a specific data range. So for example, here I'm saying print word game from 3 to 6, which means if we go back to our board, we get the 3. It's 1, 2, 3. So I want the column, the third row from the index 2 until the index 6, which gives us our first sheet. Yeah. So that means that we can not only allocate elements within the data frame by giving the exact coordinates, but we can also allocate chunks of data within our data frame. So we can get a single data element as well, 7, 5, 7, 5, another sheet. So you may be lazy as me, as we all humans are, right? So it's really bothering to be typing every time. It may look cool, like doing like this, but it's not useful and it's not efficient most of the time. So we use functions that are like already written steps that the computer knows to do something. There are some R code functions like the ones we have used already, like print, that is give me within the console this. Data frame, that converts something into data frame. R-bind, the thing we made to do our matrix. C, blah, 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 blah. So here I made a function for you. It's called naval turn. The way we declare a function within R is we have a variable name, let's call it, that is going to allocate a function. Then we use the allocate symbol, the little arrow. Then we say, oh, this is going to be a function. So we call the function the thingy. And then we use which are the arguments that we are going to use. It doesn't matter if you don't remember at the long term. The HTML is for you like to scroll of it over the time. So here I'm telling that this function is going to use a data frame, a y coordinate, and an x coordinate. Then I'm telling, well, if, just like humans, if whatever is contained in this data frame is different from none, I mean a character, then print me or return me whatever is over that cell. Then I want you to also print boom, because I found a ship. And then because the ship is, well, at least that part of the ship is dead now, change whatever is inside, return a none, because it's drowning. If you don't find something that's different from an ant, you have to tell me, oops, I failed. So I run this. And for example, if I have this saying like, I have my board game DF, which is this variable. We want the 7.5 that we already know that it's a ship, right? Then we call our function enable turn. We give the first argument, which is a data frame. We give our y coordinate, 7, and our x coordinate, 5. And it's gonna say ship, boom. If we go back to our board game, because it's already drawn, it's converted to none. So this is where the first game starts. You have to, well, only if you want to, change all the board game from ships to nuns. Does that make sense? I tried. No ships on site. No ships on site. I'm sorry, I know that coding is boring sometimes. Are you done? I think I'm gonna move on because we need also to plot shiny stuff. So what we did, as I told you, is we have an if here, checking if the condition is true or not true. So if this is not true, well, if it's true, then do this. If it's not true, then do that. Another thing that you're gonna use a lot is for things, for loop structures. And the syntax for this is for each element within an element container, that in this case, it's gonna be, for example, for each column within our board game data frame, it's gonna tell us print running this step. It's gonna print the column. As you can see, column is like a temporal variable that's gonna contain each one of the columns, right? It's gonna be overwritten each step. So when you run this, it gives you like running this step. The first step is gonna be nan sh, which corresponds to this one. Oops. then changing step, because that's the end of our for condition, and then it's going to start again. So it says running this step, but it changed the column. So the way to think about this is that when we have a defined amount of elements within a structure, we can have as many steps or as many things within the loop as we require. That means that our loop is going to run as for many stuff inside our data structure. Another, yeah, so exactly. It lets us iterate around the fixed and predetermined elements of sets. It could be a list of numbers. If you can go around like subjects, like you have a list of subjects. So for each subject, calculate the mean, the standard deviation, or whatever like that. You can have a vector instead of a list, or stuff like that. Or in this case, we have columns, so with data frames, well, vectors, which are being called within each one of our data frame, because it's returning us a vector. It's storing data within the column as a vector. Another thing that we're gonna use is the while loop. That is just as it says, while some condition is true, then do something. So for example, here I predefine I to be equal to 0. And then I told, while I is less than 10, print I, give us a funny text, while loop goes brr, and then sum I equals I plus 1. So what is happening is that at the beginning I have a 0, while loops go brr, it sums, and I get a 1, while loop goes brr, and the same stuff happened. Until I have the whole condition. That is, I get a 10, but 10 is not minor than 10, so it kicks us out of the while. The problem with the while loops is that, as you can see, you have a predefined amount of steps. The amount of steps depends on a condition either to be true or to be false. So sometimes you may not, because I've done that, you may not really be thinking about the condition. And so you have a loop that runs infinitely and that gets a lot of RAM memory. So you're not gonna stop your for loop, your while loop, and your computer's gonna get mad. And you have to do IT vibes and turning it off and on again. Okay. Now we're going to talk about libraries. I'm really proud of this meme. So for libraries, we have a different kind of steps. First, we need to install libraries. In this case, Gandalf is installing Flash Spell. That's meaning that you have to take it from the cloud to your computer. Then we have to load it, so keep it on hand. Flash Spell. Then we have to use whatever is contained within it. That here is a function that's going to be applied to the valve rock. And the result of our function, as we have seen, is you shall not pass, right? You can do the same for a lot of things. So there are a lot of libraries and people who do that because there are a lot of really nice people who think for us and write code for us so that we can do less coding and more plotting. Those are called packages. So first, you have to think about the package as you are the same elf who do magic. Sometimes instead of wanting to invent a new magic trick or spell, there's another elf that has already written it down over a grimoire. Grimoire?
Yeah.
Grimoire. I got that one. Does everybody know what a grimoire is?
Oh.
A spell book, yeah, exactly. It's a spell book, so you may want a spell book. And so in our spell books are called packages. So first we have to install the package. You have to get the book because you cannot use a spell if you don't have the book. You have to load the package, which means that, oh, I already bought this book, so I have to keep it close to my desk because I know that I'm going to use some spells within that book. So in this example, I'm going to show you how is the basic way of installing packages. So here I'm installing Pacman, which it doesn't mean the yellow ball, even though it could. It's because it's Pacman because of package manager. Boom. They are really, really smart. So if we run, well, I already have it installed, but if you run install packages, it's gonna give you a lot of stuff. Taka, taka, ta. And in the meanwhile, while you are like installing your package, you may ask, because you are really smart people, where are these packages coming from, despite of another guy's computer? They are coming not from God and not from the R God. They are coming from some place called Comprehensive R Archive Network. CRAN for cool people. Yeah? CRAN.
No, I'm sorry, that was just me.
Crane. Yeah, so it's really, really boring stuff. But here you can find everything that people has been loading to do like some open source things. So there are a lot of libraries. There are some libraries to make memes, which I don't understand, sadly. But so yeah, it's good to know that they are coming from here. There are also something called mirrors. So here, if you go to packages, you can go to install. So you can get the repository. That's actually the thing that cron. Here you write the name of the package, taka, 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 taka. And here it says where it's gonna be installed. It's also good because here you can see everything that you have already downloaded, even though it may be not loaded. So it's like your library of grimoires. And if you don't want to do the console thing, you can update packages from here. You can search from them here. Pacman, woohoo! Ulmer, woohoo! I know it's not fun, but I'm trying my best to make it fun. Oh no. No. Oh my goodness. So the reason I asked you to install Pacman is because I wanted to teach you to install packages. How to load them is with the library function. And then finally, it's because we have a default package manager within R. That's the one we use when we say install.packages, whatever is inside. Thus, sometimes it may get a little bit angry because you need some dependencies. So imagine you are wanting to learn a spell in dwarf language, but you're an elf and you don't know dwarf. So you're not gonna make magic with that. You would need something that translates dwarf language to Elvish so that you can actually read it. Sometimes the default package manager is smart, but the yellow eating ball is smarter than the default one. So in this case, the way you would call it is Pacman 2 points payload, and we say the amount of packages we want. This is used. Why you have an error?
Drag your text box.
Oh, sorry. This is useful for 2 reasons. First, when you're wanting or you want to share your code with someone else, instead of those people having to install the libraries they don't have, loading the libraries they need, they can only install Pacman and then run Pacman payload. And Pacman is going to be smart enough to see like, oh, do you have this grimoire within your library? No, you don't have it. Then I'm going to get it from the a grimoire store. Oh, you need the dwarf translator. I'm gonna get it for you. And so you can get everything done in a couple of lines. And that's make your code really easy to share so that you don't get like these errors of, oh, I don't know this function because I don't know that grimoire. And the way to understand this is because it looks a little bit scary, at least for me. From the library, use the function. So that's what the double 2 points means. Imagine you have the library. Instead of the 2 points, imagine it to be a page within the grimoire. So it's saying within the grimoire library, give us or do something with the spell on page 60. Does that make sense? Thank God. We have done a lot, even though it doesn't appear to. Well, at least I have done a lot. I'm sweating a lot. So now opening CSV files. What are CSV files? Well, CSV files are comma-separated files, which that means they are only fancy .txts, where we separate each column with a comma. Well, we also have TSV, so we separate them with a tab. Wow. So for example, we can load CSV files as they are plain text. They are not going to have fancy colors. They are not going to have bold. They are really, really boring stuff. I like boring stuff. Or you could, if you prefer having an Excel file that you can put like, oh, this participant was really a naughty boy. So you can put them, highlight that in red. And you want to remember every time you open your Excel file that that participant was a naughty boy, you can save them in Excel. Yeah, because you don't want to forget naughty boys. Yeah. You're gonna tell Santa so that they don't get anything. For that, we're gonna use, for example, the read Excel package. And what's going underneath is like long story. The function read Excel is gonna get the Excel, and it's gonna say, okay, I don't care about who's being a naughty boy. I only care about the text within the Excel file. So I'm gonna translate it kind of like a CSV, and then I'm gonna make a data frame with that. Although there's something really, really important, and that's the path. So you have to tell the computer where to search the data. And the mainly difference is that Linux and MacOS users, they have the path delimited like this, and Windows like this. That doesn't make sense? I don't know. I don't make the rules. They are the dark side. I don't make the rules. Well, actually, I flipped the image, so I did make the rules, but don't tell anybody.
I like the prompt savers.
Yeah. In case you forget, here you say Linux, MacOS, taka, Windows, taka. So let's start doing the little words. So here I'm saying like, within the CSV file variable, allocate me whatever the result from the CSV thingy. So here, if you downloaded data from Google Drive instead of my GitHub, this is not gonna work. But the good thing about RStudio is that we can push the tab button, the one with the arrows this way. And we can go around. You see? If you go around within the same directory you are. If you have to go to another directory, you can go to the files and start searching around here. And then, like, for example, I'm going to put my whole path, home. So I'm going to write home. Oh, because I forgot this. Home. Okay. And you don't have to worry about not finding your stuff. And here I have data, exercise, CSV. And here I have my CSV file. As you can see, It's a data frame. Ah, heterogeneous data type, which contains 3 columns: column dataset, column X, and column Y. We can do the same for Excel. Remember, from the grimoire read Excel, use the function read Excel as X over, you change here the same. Ooh. Which is also a data frame. Okay. Something that you have to take in account in audit that we have already said. You have to remember that every time you're loading a CSV, each one of the columns is going to be treated as a vector. So if there's, just a reminder, if there's a letter within a column that's only supposed to have numbers, it's going to treat everything as characters, as strings. So you're going to really pull your hairs because it makes no sense when you're trying to do something. Yeah, so that's like, but now everyone's here because of this. Because R is really known for making cool plots. And we want to have that power to please our supervisors. For that, we want to use the ggplot2 library. And the way to understand ggplot, because at the beginning, it makes no sense. We're going to go line by one. And also, by the end of this, well, I put some code that you're going to be able only to copy paste every time you want it, to change a little bit stuff. So you always have nice plots. But the way is that we have a data structure that it's always or almost always going to be a data frame. We have the mapping. That's when we are telling ggplot, I want a box plot, I want a scatter plot, I want a baba plot, whatever kind of plot you need. Then we have the layers, we have the scales, we want, like, if you want to change the x-axis, the y-axis numbers, blah, blah, blah. You want to change coordinates in case you want different plots within the same image. And then you have the theme. That's what makes cool plots. You can find everything here within the ggplot intro, the ggplot cheat sheet, and the element text. So now we're going to go line by line within the core. So first, these really, really scary tons of lines give us our plot. So the CSV that we uploaded makes Barney appear. And as you can see, Barney is color Barney. So every time we are using, we are plotting stuff, we can use hexadecimal color codes. And the cool stuff about RStudio is that it's smart enough to show us the color. Huh? So now let's read it one step at a time. Remember, we have data. So we call ggplot data layer over CSV file. CSV file, this one. Oh my goodness, I'm so nervous. Over this data frame, I want you to plot something using, because you may have a lot of columns. Using the columns for the X, we want X. For the Y, we want Y. Thus, sometimes you may have a lot of conditions or a lot of factors within the same document. So it's a good call to separate them. Like instead of having points, you would like some triangles, some crosses by shape, or you can color them by the same category. So here, as data set is going to be like our factor, we can have like Barney, Baby Bob, I don't remember all the other names, but yeah. And you can have a color for each one of them. So that's the first layer, the data layer. Then for the mapping one, we want geom points. How many data types there are? Thanks that you asked, even though you didn't. No, ¿dónde está mi liga? Ah, here. We have the cheat sheet where we can see how to change some stuff, how we can make these kind of plots. You can use this kind of plots, depending if we have discrete variables, if we have continuous variables, we have primitives. And yeah, so that's the thing, like here you can find each one of the different kind of mappings that you may need. In this case, we're sticking to a scatter plot. Then we are gonna give the layers. Each one of the layers is defined here with a plus sign. So ggplot works like Photoshop or GIMP. It's a layer over a layer. And the way that we tell ggplot to add a new layer is with a plus sign. Sometimes our people are not that bad. I like R.
Which is nice because you can actually, if you want one image to be on top of another, you can rearrange the layers and it just quite literally, you can decide which one goes on top. So that's the one thing I do really like about
Yeah,
the layers.
that's true. Yeah. Drew is saying that it's really cool because you can decide what's go on tops on what's, giving the plus sign. And also, yeah, it's really convenient. It's so convenient that people are making wrappers for ggplot to Python. And I use them because they have cool plots. Yeah. So here you're saying like for this layer, the scale color, scale, see? We want the values of the colors of our scale to be Barney color, like. Next layer, Taka. The facets. We are gonna design the labels for our plots. So for the X, here I put X axis random, but I can say, where are you, Scooby-Doo? Huh? It changed the name. So you can actually say whatever you want here. If you would like to put, and the same stays true for the Y variables. So you can say, I really want to take a nap. Hey, we also changed that one. So that makes really useful to change the labels. That's something that a lot of us struggle to. Then we can say we can change the title. My amazing first Jedi plot. What it could be, why am I still here hearing this guy? Ah, yeah, I totally feel you, and I'm so sorry, but then here we are using a continuous scale. Everybody knows the difference between discrete and continuous, right? Okay. So because we are using a continuous scale, we're using scale X continuous, but it could be scale X discrete. So here we're saying over this axis, I want you to make some breaks. So that's whenever it's gonna put some text. So for example, here, my plot goes from 1 to 100. My breaks are gonna be 1 and 100 because I only want to have some words here. But this has to be a vector that contains the actual values of your data range. So these are the range driven. Then you can say the limits of your plot. Here I put 1 and 100 just to make it really center, but I could put 1 and 200, and it moved my plot. We can say 50 to 100, and it's cutting my dinosaur. So a lot of times you're going to use also this because you want to center your data or you want to rearrange it. So that's also useful to know. And then now that we already put where I want my breaks, I can define what my levels are going to be. So here I put, oops. But and but I can say 1 and a lot. And we're gonna changing the labels. It looks neat here. The same stands for the, let's see, for the scale J continuous. It's the same if you do it with discrete variables. Also, it's going to be useful sometimes to know which kind of variable of data you have. So it's always useful before plotting to see this, like to actually see the data frame, and to see the data type within the same variable explorer over the environment. Yeah.
So here, when you scale the remote axis, you actually create the breaks because your data doesn't have any. But if imagine that I have in my data frame time, and I want just to move, as we did, you move you center. I have to put both breaks and limits.
No, you only have to change the limits.
Okay.
Yeah, because you can have that break that's outside the limit, and then you're not gonna plot it. Yeah.
And another thing that comes up a lot with people data is if, for example, the time variable, maybe 500 is the start, and on your plot you want it to say 0, you can sort of do it Marco did here, and you can rewrite it on your plot using this simple command.
Yeah. So Drew say that it is also useful because if your data starts with 500, the onset of your stimuli, you can change the label to 0. Yeah. And now the fun part, the themes.
In another thing that's been useful to define value would be beyond the factor.
Yeah.
Okay, when you have multiple factors, how do you have
That's gonna be the game.
okay.
Yeah, because we have another data, the one that's called numeric peekaboo. So I'm gonna do the same. Hold a second. And it's okay, I'm gonna see because I also want to see if you laugh because for me it was funny. CSV. Numeric peekaboo. CSV file. Oops. Oh yeah, because I only have one color. Let's comment this out. Oops. Where I got it? It's called label. I was a naughty boy. I wanted to make you have an error that I just had. Yeah. So the game here is to, well, as you can see, I have the same like shapes. So I have different shapes. I have a color for each one of the shape. I could take that out, for example, and everything would have the same color, but different shapes. I can instead only change the color, but use the same shape. But yeah, so the idea here, at least for this kind of thing, is that you have to make a sub data frame only containing each one of the labels. Yeah. Here you can see I have a panda. The other things are a mystery.
But do that before plotting it.
Hmm.
So refresh the data that plot with modern version.
Yeah, you have to know your data type. There are like another ways of doing it with I think it's data wrangler, where you can actually put like one side to another one. But that's like kind of wizardly that we are not gonna be doing today. And just before I finish, here is the fun part. The theme. So for example, the theme here is gonna say that the background is gonna be white, because most of the times we don't want to have like those codes that are given by default. That's not neat. We can change the color of the outline. Like here I put gray, but you can put black. It's a color. It's black color. So what's gonna happen? Oh, what a surprise! Now it's black. We could put as well green. Okay, it's green. We can change the color of the subtitle, the title, so here I want to have pink, yellow, red. Ah, it looks awful. Yeah, and there's another thing that you may need as for the axis. So I put the angle, because sometimes you may have a lot of words. For example, maybe people who use words, you may want to put them and they're gonna like be one on top of another one. So you can put, for example, 45, which are the degrees. And then you can actually change the orientation of your text. And you can do whatever you want. If you want to put it upside down, you can still do it. And you can also change the family font. Here I'm using Apple Gothic because I want it to be mysterious and dark. But if you prefer to be happier, yeah, we don't like happy people. No, we do like happy people. You can go to this URL and see like the families that we have. Like you can change the font face, the color, the justification in X, blah, 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 blah. Yep. And you can also see like our font families.
I like the brown.
That's good. And here you have, for example, sans. And you can do a lot of fonts that you can be changing, Helvetica, Times New Roman, if you want to be boring, Courier, blah, 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 blah. And also for the, like, now that we're talking about colors, I also add like some reader recommendations within the things, but it's also good to check Color Brewer, because sometimes we forget that there's colorblind people and our plots are not going to be friendly for them. So if we go to this really nice thing, we can say like, I want diverging data frames. I want to be colorblind safe. I don't want to use a lot of ink because I'm ecological. I want to be safe for making like some photocopies, like black and white. And then you can get the color in hexadecimal, you can get the RGB, CMYK. But you have a lot of things to choose. Here I only have a color scheme, but for example, if I would like, let's say, sequential, you can have a lot of different color schemes that still looks pretty. And they are more inclusive to other kinds of color perception within people. Look at this. It looks, yeah, this looks pretty. We are doing science. Yeah, and lastly, before like going to the plotting parts. Look at me using the mouse. Here. Remember that whenever you don't know something, you can always ask Gemini, Google, ChatGPT, or Stack Overflow. And here are some references. And yeah, so the exercise is only like using numeric peekaboo to separate the data frames and to see which animals I hid over there. And also, I didn't make that because I'm not that smart. There are some people who already did a library to change them. And it could be a good practice for you to try to take out the mean and the median, like to look after Google, because you're going to get the same mean and median. So what I'm trying to push by this is that before doing stats, always plot your data, because here you're going to have different animals, just as we saw here, but the central tendency measurements are the same. That's people. I think I can actually have an animal that's giving, that's larger. Yeah. Here I have a rabbit. Yeah. So next time you want to do some fancy plots, you only have to copy paste from here downwards. Once you have already like decided what's going to be like the font you want, the color scheme, blah, 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 blah. And you only have to change the first two layers of the ggplot, the data and the mapping. And that's cool. Well, I think it's cool. You can also change the lines. Here I have solid. Well, for example, we can put dotted. And what is it gonna give me? Dotted lines. And yeah, that's as fun as it's gonna get. I'm so sorry.
Thank you.
You're welcome. I'm dehydrated. Okay, I'm gonna stop sharing.